Welcome again. In this presentation, I will explain the effect of dynamic pre-filter on PID controllers. We will include a dynamic pre-filter, we will split the controller in PI-PD form, and we will verify offset free tracking. Here is the filtered PID control modified to take care of kicks. Now the reference signal comes in integral form. It also comes partly in the proportional mode. This is done so as to increase the speed of response, and we have used E of t equals RT minus YT, that is an error term. We will take B to be in the range 0 to 1. This is known as PI-PD controller. We have forward difference approximation for integral, and we will apply backward difference approximation for derivative. So we will use forward approximation here, we will use backward approximation here. When I do that, I get the following discrete time form. The first two terms come over here, then I have this error term E of t given by RT minus YT, and for 1 over S I will use forward difference approximation. So I get this is a forward difference approximation times 1 over tau I from here times Rn minus Yn minus, I need to substitute for S in these two places using backward difference approximation. So here is the backward difference approximation for S, and then I complete this control law. There is no hard and fast rule on which discretization to use. Here I have used the same approximation used by Astrom and Wittenmark. From the previous slide I get this expression. Let us simplify this. I have mainly simplified the last term here. You can verify this. Let us start with that. We can rewrite this as follows, where I have introduced the symbol AD, where AD is given by this. Once again, you will have to make sure that these two expressions are identical. Let us start with that expression. Multiply both sides by the denominator here, namely z minus 1 into z minus AD. I get the following expression. So the left hand side gets multiplied by that, the right hand side gets simplified by that, and we have introduced new symbols BI and BD. Once again, you have to make sure that you can derive this expression starting from here. Okay, this is the expression from the previous slide. Let us divide by z squared and rearrange. So the left hand side becomes 1 minus z inverse into 1 minus AD z inverse. Here you had z squared, highest power is 1, and then you have z to the power minus 2 here, times u equals on the right hand side k into constant term, z power minus 1 term, z power minus 2 term into r. So all r terms from here are grouped and written here. Similarly, all y terms are grouped here. Once again, these are the coefficients of z power minus 2, z power minus 1 and the constant term. Once again, this is of the form RC times u of n equals TC times R of n minus SC times y of n. This is our standard 2-DOF form. You can check that TC of 1 equals SC of 1 equals this expression. For the first time, we have the TC expression also containing powers of z power minus 1 and z power minus 2. Until now, TC was a constant term. Only here for the first time we have dynamic terms in TC. So we have used dynamic pre-filtering in this problem. Let us conclude this presentation with a general strategy for discretization. We identify a structure with no kicks, it is bumpless, etc. Identify a discretization strategy that will avoid excessive oscillations, be implementable or realizable, and be easy to implement. Finally, it should ensure offset free tracking. With this, we have come to the end of this presentation. Thanks for joining. Goodbye.